This time we're going to look at how to use sine, cos and tan, but find unknown angles. So last time we were looking at finding unknown sides. We're going to do exactly the same thing, but finding unknown angles this time. So again, we're going to be using the exact same rules, SOHCAHTOA. So we're still using our sine, cos and tan ratios in the same way, but this time we're finding a different piece of information. So let's start with sine. So this time I'm going to give you the side lengths, but I'm going to call this theta because we don't know what it is. So I'm going to call this 10 centimeters and I'm going to call this 14 centimeters. So what angle does this have to be to make those two lengths true? Well, obviously this was our rule. Sine of the angle is the opposite over the hypotenuse. So that's what we're going to do. So sine of the angle equals the opposite, which is 10, over the hypotenuse, which is 14. Now, the way of undoing this, a lot of people try and divide by sine, but that doesn't actually make any sense. Sine always has to be attached to an angle in trigonometry. So what we're going to do is do the opposite of this, which is actually called an inverse function, and we write it with a little -1. So all you have to do is type that into a calculator. So we say the inverse sine of whatever we were told to do, this ratio, is the size of the angle, and I'll show you what that looks like. So if I type in, so you might have, so I have to press, you might have like a shift button or something, and above your sine button, you'll have like an inverse sign. It'll look like that with a little, I don't know if you can see that, with a little -1. So if I do the inverse sign, and again, I'm using a fraction, but you can just do division if your calculator doesn't do this. So I type in the inverse sign of 10 divided by 14, and I get 45.58. 45.58 degrees. And that's the size of the angle. So there's a lot less steps to this one. This is a lot easier. You just need to remember that it's an inverse function. So let's do one more of those. If I draw another triangle like this, I don't know this, and I'm going to say that this is 24 meters and that this is 32 meters. And I want to know what that angle should be to make this true. So again, I use this rule here. I say sine of the angle, which we don't know, is the opposite over the hypotenuse. And then I just find the inverse of that ratio, 24/32. So again, I'm just going to type that in. The inverse sine of 24/32 is 48.59, sorry. 48.59. And this is true for all of the other ratios as well. So if I'm going to do another one, let's call this one cos. Right, so I don't know this. I'm going to say that this is 12 meters and that this is 20 meters. So this time, that's my opposite, right? I'm not using it. I have my adjacent and my hypotenuse. So I say cosine of the angle is the adjacent over the hypotenuse. And then I just find the inverse of that. The inverse function of cos of 12/20. Again, I just type this in. 12/20 is 53.13. And the same thing applies for tan. Okay. Try and draw one that looks a little different to normal. I don't know what that is. This is going to be 8 meters and this is going to be 13 meters. So what angle does that have to be to make this true? I use my tan function this time. So I say tan of my angle is, according to this, my opposite over my adjacent. So my opposite is 13 over my adjacent, which is 8. So then again, I find the inverse of tan of 13/8, and I just type that in, is 58.39. All right, so it's just that easy. Finding angles, there's a lot less work to it. It's just a matter of remembering every time you find an unknown angle, you're using an inverse function, and every time you're finding an unknown side length, you're just using normal sine, cos, and tan. All right, good luck.